failed space missions. Not the famous disasters, Challenger, Apollo 1, the obscure failures, probes that silently died, missions cancelled after billions spent, satellites lost due to a single line of code. Framed as a graveyard tour with real telemetry data. In 1999, NASA lost an entire spacecraft. Not because of an asteroid. Not because of a solar flare. Because one team used metric units and the other used imperial. $125 million. Gone. Because nobody double-checked a unit conversion. And that's not even the strangest failure in space history. Today, we're opening the graveyard NASA and other space agencies don't like to talk about. The missions that failed quietly, expensively, and sometimes mysteriously. The graveyard of space missions. We all know the famous disasters. Challenger, Columbia, Apollo 1. Those get documentaries, memorials, tribute videos. But there's a whole second category of failure. The kind that doesn't make headlines. The kind buried in post-mission reports nobody reads. Missions that vanished without explanation. Billion-dollar programs canceled after a single word from Congress. Satellites destroyed by a typo in the code. This is that story. The silent mistakes. Let's go back to that $125 million mistake. NASA's Mars Climate Orbiter was built to study the Martian atmosphere and act as a communications relay for future missions. It was going smoothly until the final approach. One engineering team at Lockheed Martin calculated thruster performance in pound-force seconds, an imperial unit. NASA's navigation team assumed the data was in Newton seconds, the metric equivalent. Nobody caught the mismatch. Not once. Not in a single review. The orbiter came in about 170 kilometers lower than planned. So low it either burned up in the atmosphere or bounced back into deep space. To this day, nobody knows which one happened. It just stopped talking. An entire spacecraft lost to a conversion error a first-year engineering student could catch. Beagle 2, 2003. Here's one that's even stranger. Because for over a decade, everyone assumed it just crashed. Beagle 2 was Britain's ambitious little Mars lander designed to search for signs of past life. On Christmas Day 2003, it separated from its mothership and went silent. No signal. Nothing. For 11 years, it was written off as a failure, presumed destroyed on impact. Then, in 2015, NASA's Mars Reconnaissance Orbiter caught something in high-resolution images. Beagle 2 hadn't crashed at all. It had landed successfully. Perfectly even, but 2 of its 4 solar panels failed to fully unfold, covering the antenna it needed to phone home. It had been sitting there the entire time, alive in a sense, just unable to speak. The buried billions. Constellation program, 2004-2010. Not every failure is a crash. Some failures are just cancelled. In 2004, NASA announced Constellation, a program to return astronauts to the moon and eventually reach Mars. New rockets, new capsules, a new era. Over the next 6 years, roughly $9 billion went into development. Then, in 2010, it was cancelled. Not because it failed technically, but because of budget overruns, schedule delays, and a shift in political priorities. $9 billion of hardware, research, and engineering shelved. Some of it later reused for other programs. Most of it gone. The satellite lost to 1 line of code. This next one should terrify every software engineer watching. In 1962, Mariner 1 was meant to be humanity's first flyby of another planet, Venus. Just minutes after launch, the rocket began veering off course. Range safety had no choice but to destroy it. The cause later traced by investigators, a missing hyphen in the guidance software. 1 punctuation mark. 1 symbol. Arthur C. Clarke reportedly called it the most expensive hyphen in history. An entire mission vaporized over the Atlantic because of a symbol smaller than a fingernail. Bereshit and the silent cutoffs. Some missions don't fail loudly. They just stop. Deep space missions rely on a constant thread of communication, a signal thinner than you'd expect, stretched across millions of kilometers. Sometimes that thread just snaps. Probes have gone silent mid-transmission. Engineers watch the last data points arrive, and then nothing. No error message, no final words, just silence where a signal used to be. For weeks, sometimes months, teams keep listening, pointing dishes at empty space, hoping for a whisper that never comes. Eventually, the mission is quietly reclassified. Loss of contact. 2 words to end a project that took a decade to build. The graveyard orbit. And here's something most people don't know. Dead spacecraft don't just disappear. Many of them are still up there right now. There's a designated region called the graveyard orbit, a few hundred kilometers above the operational satellite belt, where retired satellites are deliberately pushed at the end of their lives so they don't collide with active ones. Right now, silently circling Earth, there are decommissioned satellites, dead probes, and abandoned rocket stages. A literal graveyard orbiting above our heads that most of us will never look up and think about. Every one of these failures cost real money, real years, real careers. But here's the thing that doesn't get said enough. Mars Climate Orbiter's failure completely rewrote how NASA handles unit verification, a mistake that will likely never happen again. Beagle 2's story quietly reshaped how future landers deploy solar panels. Mariner 1's missing hyphen led to some of the earliest formal code review processes in software history. Nothing here was truly wasted. Every failure left something behind. A lesson, a fix, a protocol, buried in the foundation of every successful mission that came after it. The graveyard isn't just where missions go to end. It's where the next ones learn how to survive. If you want the story of the mission that did leave Earth's solar system and is still talking to us 50 years later, that's next.